Alright, so 2 years ago, I began a journey and I built a robot arm. This one. And it promptly broke. And here it is now. Ooh. So, this summer, I had the great idea, since it's been 2 years, why don't I just make another one? And I did just that. Check it out.
That's good social media.
Hey everyone, I'm Mark Goldbeck.
I'm Dylan Reese.
And together, we made a robot arm.
Yep.
I built the thing.
And I programmed the thing.
The idea is that this was inspired by all the open source 3D print robots out there and by Universal Robots. This was mostly, I'd say like more than like 80% all 3D printed parts. I got some PVC pipe in there, and we got our little GoPro over here. The way I made this is that I made an overall casing around it, and I hid all the electronics inside of the casing, so you don't see the wires. And I purposely built it so all the wires weave through the exact middle of the robot, so nothing gets tangled ever, and you have a lot more degrees of freedom where the arm could move way more than normal, and it won't always bump into itself.
So 2 years ago, you were using worm gears back then.
Yeah, and the idea about the worm gears is that you get a lot more torque out of it, but the way gears are by nature is that there is a little bit of give on them, so they don't have that much precision. So actually this time around, because I've gotten a few years worth of experience with 3D printing, I actually use belts and pulleys and stepper motors just like a 3D printer, or you would see maybe on a CNC.
Right.
And so we get less torque out of it, but a lot more precision.
Exactly. And that precision makes the programming side a lot easier, because now I don't have to worry as much about things slipping and things doing different or having different issues.
Well, not necessarily slipping.
Well,
because
unfortunately, that ended up becoming a separate issue with this project.
Yeah, so what happened was I was using a belt rated for 60 pounds, but due to unforeseen circumstances, there actually isn't that much grip power within the pulleys themselves. So when they go beyond a certain angle, they do slip, and we can't get it to go that far within the shoulder right here. This is about its limit right here.
Yeah, but better design, better materials, this is not a huge problem because this is a very fixable issue.
Unfortunately, we never got around to adding the 4th and 5th axes because of the limitation of some of the mechanics we have here, because this is freely rotating on here. So in the future, when I work on this some more, I'm actually going to get better parts, better pulleys that have better grips, so this thing will actually have a lot of freedom, because I'm actually going to do it now. Once I put too much force on it, right, it starts to really fall, which is not good. So if I had pulleys with much bigger teeth, they'd have better grip, and it would stay still, actually. So I'm going to let Dylan actually explain how he actually programmed this from the start. So you take it away, Dylan.
Yeah. So basically, the difference between back then and now is I was trying to hard code everything on the Arduino. We switched from the Arduino to the Raspberry Pi, so I used the Raspberry Pi GPIO to develop a library that allows you to write a single line of code to control as many motors as you want simultaneously. Unfortunately, I wasn't able to work out the kinks for getting it to move at different speeds or different micro-stepping settings. However, right now this robot is able to move into different configurations at the same time with a very simple library to use. Currently for the Raspberry Pi, there is no open source stepper motor library. I believe there is one for servo motors and basic DC motors, but specifically for steppers, there's nothing. So I had to create a library from scratch, which was a lot harder than you would think it would be to get this robot to move into different configurations. Essentially, what the Raspberry Pi provides for you is it allows you to control each individual input and output pin to control the motors, meaning you can only control one single motor at a time. With my library, with one function, you're able to control as many motors as you want simultaneously to different degrees, moving them to any degree position you want. Another thing that did not end up getting done with this project that I really wish got done is I built a simulator for this robot that basically took it from the side view right here. As you can see, these three little circles. And essentially what it did is it would mimic the robot's position on a two-dimensional scale. Unfortunately, I was never able to link this with my stepper motor library, allowing it to actually follow the robot's movement as it moved.
Alright, as you can see, this simulator resembles the robotic arm with the three circles as the joints and these three parts as the line segments. So with this, what we can do is we can have an exact degree number, which is the speed right here, and you could set it so that every time you hit the arrow keys, it moves that number of degrees. This also allows you to control the actual robot. Since the stepper motor library allows you to move a certain number of degrees, you simply pass the number of degrees from here into that, and you're good. It works.